Hello all, welcome back to the session. So today's topic is multi-tool agent collaboration. So this is our next step towards agentic AI, correct? So in past few days we learned about LLM, we learned about agents, we learned about tools, we learned how to use each of them and what role each of them plays, correct? So all these things have been explained. So today we are going to see how multi-tool agent collaboration can happen. So the agenda here is to learn about different patterns which which comes with agentic AI. So we are going to learn different patterns or workflows. So first one is sequential workflow, then hierarchical workflow, then dynamic decision making patterns, parallel processing, dynamic hands off, self correction, and auction based delegation. So these are different ways in which two agents can collaborate with each other, correct? So that collaboration is what we are going to discuss today as such. So the first one is sequential workflow. This is also known as pipeline. So this is a very simple pattern. So here we have multiple agents. The output of one agent will serve as input to other agent, correct? And it will follow a chain or a pipeline, correct? Till we get the final output. So that's why it's known as sequential workflow. So you can see the pattern. Agent A is there. Agent A will talk to agent B. Agent B will talk to agent C, and final output will come, correct? So the output of agent A will become input to agent B. The output of agent B will become input to agent C, and the final processing of agent C becomes the final output, correct? So you can see the agent roles are there. Agent A can be a researcher. Agent B can be a writer, correct? Takes the raw data from agent A and drafts a cohesive report. And agent C can be an editor who takes the draft from agent B and refines it for clarity, grammar, and note. So each agent has set of responsibilities which they will do on the input which they receive before passing that to output, correct? So the second pattern, which is also known as supervisor sub agent pattern, this pattern is known as hierarchical pattern. Now here what happens is we have a special type of agent with name supervisor agent. What will supervisor agent do is they will take a user request, break it into subtask and delegate the task to sub agents, correct? So someone will take the responsibility of coordinating, that is the supervisor agent. From the user, whatever request comes, that request will be divided into subtask and sub agents will be assigned subtask, which will be then collected together and given response back to the user, correct? So here the supervisor agent does two things: dividing the task and collating or collecting the output, correct? So that two things supervisor agent does. So as an example, you can see supervisor agent can be a powerful LLM, and sub agent 1 will do code analysis, read a code snippet and check for bugs, and sub agent number 2 can perform documentation writer, correct? So they can write a doc string for the code. So here the role of sub supervisor agent becomes very critical, because supervisor agent is responsible for taking the request, dividing into task, processing, and so on, correct? Same way, the extension of hierarchical is parallel processing. Okay, so it's also known as independent task pattern. Now, why this pattern is so powerful is because it have multiple agents which can run in parallel. Since multiple agents are running in parallel and doing tasks in a parallel fashion, this will result in faster delivery, correct? So you see coordinator is there, coordinator. So agent A as task 1, agent B as task 2. Both are independent tasks, so they can run parallelly. And after running parallelly, there will be an aggregator who will aggregate the results and give, correct? So this is a powerful feature. Why? Because we are running things in parallel. Of course, this will apply only if we can run things in parallel. So if you see the agent roles, there is a coordinator agent, agent A, agent B. Agent A is a market researcher, agent B is a news analyst, an aggregator agent which will take the output from each of them and combine them into single investment. Get it? So that is what we call as parallel processing. Next one is again a very powerful pattern. So we saw so many patterns. We started with single pipeline, then we saw how we can make use of coordinators, then how can we run parallelly, correct? We also have dynamic handoff. This is also known as gated transfer, correct? So in this pattern, what happens? There is an initial agent. If the initial agent is not able to handle the query, then it will forward the request to a specialized agent. Okay, so initial agent, it will keep on forwarding to specialized agent till you get the final output, correct? So there is a handover. So this is known as handoff. It generally comes from a call center pattern where if a particular agent is not able to answer the question, that gets forwarded to next agent who can answer the question, correct? So if you have worked with any support systems, you can say L1, L2 support, L3 support, same way, correct? So there is a level who will try to solve the problems. So the initial agent handles the request, but if a condition is met, it dynamically transfers the conversation to specialized agent, correct? So this is an example of dynamic handoff. Again, very powerful feature, correct? Now we also have some self-correction patterns, correct? So what will be the self-correction pattern do is, there is continuous evaluation happening of the output given by the agent. So a specialized agent with name critic or reviewer, they sit down means programmatically, they will analyze the output of agent and if necessary correct it and give the feedback back to the agent to improve, correct? So this can keep on happening till the critic agent approves the artifact. Okay, so you can see user, agent A, agent B. So agent B is a critic. It will keep on giving the feedback till it's satisfied that the result is as per expectations, and then only it will give you the final output, correct? So here there will be two agents or two roles of agents, one being the agent who generates the output and second being the agent who gives the feedback. So there is also auction based delegation. So what happens in auction based delegation? A task is broadcasted by the supervisor or manager to all the service agents. Now each of the service agents will bid for that capability and the manager selects the best fit based upon criteria, correct? So it's like an opportunity which is given to, which is being posted, to which many people will apply, and the one who is selected is the one who has the best offerings, correct? So it's like an interview only. So here, after broadcasting, the manager will wait for response for each of them to give the final output, correct? Yes. So this is a very advanced pattern, correct? Auction based delegation pattern. Okay, so now to do all this, we can make use of few libraries. One of the library is Crew AI. It plays an important role in sequential and parallel. You can also make use of LangGraph for complex state-based iterations, correct? It's very much preferred for graph-based workflows. And Llama Index, RAG, and orchestration, correct? Agent as an tool allows calling one agent to call another. So this can be used for hierarchy. So these are some specialized tools which will be able to handle these design patterns, correct? So now with this much information on different types of patterns which we have, let's go and see their implementation, correct? So implementation of each of this. So what I will do is, first I will say docker start llama. Okay, to first start the docker. So the first example is sequential, correct? Sequential means there are multiple agents. The output of first agent will become as input to second agent, correct? So that's what we are going to use here. So you see, we import Olama. I am creating a function with name sequential change. Topic, the importance of bees in ecosystem. So we say olama.chat message 3, and I'm giving the system, you're a biologist. Write a short detailed paragraph of the topic, and I'm giving the topic as input. So whatever response will come, that response I am giving to edit response, correct? So what will this editor do? You can see fix grammar and more tone. So it will make the tone capable of being posted as a blog, correct? And then we are printing them. You can call this sequential change. So you see, this is a very simple implementation where we have two agents calls and two agent roles, we can say. First one being the writer of the essay, and second one will be in the editor who will fix all the grammar related issues, correct? So that's what we have. So let's try running this. Let's run it. It'll take a couple of minutes, as you know, since it's running in my local. Will take a couple of minutes. As you know, running process is running on the local. Let's wait for a minute to see the output. See, this is the output of the first agent call. Very fine in the content. So we are waiting. The first output is given as input to agent 2. Agent 2 is processing that. So if you use actually a powerful server, this will be very fast, correct? Yes, you can see the output came. See it. We formatted the text to make it more attractive and readable, correct? So this is the first sequential pattern. Now we can also implement the sequential pattern by using Crew AI. So Crew AI is a library using which we can do this. So from Crew AI, we import agent, task, crew, and process LLM. Process and LLM. So I import the OS module and I set the open API key as some dummy key. Now here in Olama LLM, I say I create the object of LLM. Please remember this LLM is coming from Crew AI. It's a library which helps in these patterns. So you see model name I am saying Llama 3 and this is the base URL. The URL of my Olama REST service API is what we have put. So we have defined agents. Role is senior researcher. Goal is gather facts and data on the latest AI trends. Backstory, an expert in finding, filtering, summarizing large amount of information. I pass Ulala LLM. Allow delegation false. Tools equals tools, you know, any API calls, anything which we want, we can create in tools and verbose equals to. So first one is senior researcher. Second one, if you see, is the writer, agent. So article writer, you know, goal. Backstory also, you know, a professional content writer. Technical communication, correct? And we pass LLM as Olama LLM. Allow delegation is false, tools is this, and verbose equal true. So we created two different agents with two different responsibilities. Then we created task. Research the top 3 advancements in local LLM with Alama in past month. And we expect a structured list of key findings, equal sources, and a brief summary. The writing task using the search findings, write a 500-word blog spot, correct? And Okay, and if you see a expected output is a complete professional 500 word blog post in markdown format and agent equals writer, correct? So first agent was researcher, which we created. Second one was writer. Now I make use of crew. So crew will combine all of this. These are the agents, these are the task, this is the process sequential, and verbose equals true. Now I can say project crew dot kickoff inputs, correct? And then wait for the response. So this is how we can create. So using crew AI, we can very clearly define who is an agent, what is a tool, what is a task, what is a process, and everything, correct? You can create any number of agents with different roles. We can have any number of tasks also, and we also have crew. You can copy this. Let's run this. See, crew is running. It's executing the task. It will first do research. Again, it will take a couple of minutes because first it has to connect to internet to get the data. Then it will do research. And then it will massage the data and give results, correct? You see the UI screen or in the command prompt, the output looks quite interesting, correct? With different colors. So let's wait for 2 minutes. It will show the output. See, now it's going to the senior researcher. It's running. See, the task got completed of the senior researcher, correct? Article writer and senior researcher. This one still running. Let it finish. Let's wait for the output. Come up. This output will come. Okay, so can see the output. So first it started from here, through execution. So this is the ID. Then agent started, senior researcher, correct? Research the top 3 advancements in local LLM. So crew, senior, assign senior researcher, correct? Article writer, senior researcher, correct? It's waiting for the output to print, but you know, overall, this is the structure, correct, of the output. Finally, the sequential workflow result will come. Yes, it came. You are able to see this? The final output came, if you're able to see. Crew execution completed, final output. I can now give a great answer, the power of emotional. Yes. The references also it gave. See? So this is how we can implement sequential by using Crew AI. Crew AI is a library or a helper tool which can do this, correct? So this was the first pattern which we called as sequential pattern, correct? So now let's go to the next pattern. So after sequential, the next one was, if I remember, hierarchical, correct? So next one is the hierarchical pattern. So let's see this example of hierarchical pattern. So in hierarchical pattern, if you know, there will be a supervisor agent. The supervisor agent will get the request and divide that request to task individually, correct? So here if you see chat olama, model equals Mistral, and base URL is the URL which we gave. Here we have @tool code analyst. So code analyst analyze code for bugs and confirmed efficiency. Same way doc writer tool writes a professional Google style doc style for Python code, correct? So in these tools we have this code analyst tool and docker writer tool, and we are creating the tool names map just like yesterday, correct? Now comes the important part. Now comes agent state. So I create a class agent state which extends type date and which will have import chat history and agent outcome. Correct? These 3 things. Now what we do is list tool name map.keys. I give out the supervisor system prompt and I bind these tools, correct? Bind these tools. Then we have this run supervisor which takes states and agent state. It creates messages. First one is a system message which again comes from supervisor system.prompt where the role is clearly given, correct? See one of the tool names. If the request is not related to tools, respond directly. So we are very clear given the instructions, and in human message we give the input, correct? Then what we will do, supervisor LLM dot invoke. So here we use bind tools. I call these messages and I am waiting for the agent outcome, correct? So this is run supervisor. So when the supervisor LLM will run, what it will do, it will bind to these tools, correct? So execute tools method. So here you see I make use of state, agent state, whatever outcome comes, I make use of the tool calls. I get the name of the tool arguments and call them, correct? So here is what we are using. Selected function dot invoke. And whatever result comes, I attach that result, correct? So here one important process which comes is routing. So based upon the output, we have to call the tool, correct? So routes on whether the supervisor decided to call a tool. Yes, call tool and enter. So now what we do is we create a state graph. State graph is again provided to us by LangGraph. It's another helper library. So here we create a state graph in which we give agent state. Then in the workflow, we had supervisor as a node and call tool as a node. Then we set the entry point as supervisor, and supervisor can either call tools or he can also call end, correct? So once it ends, workflow is compiled and we give the input. I need documentation for def my function return x star to chat history, correct? And I'm invoking the app.invoke, which is our workflow. So you see, we created a workflow here with the supervisor and tools, correct? We made use of tools. So when you call the tools, it will execute and give you the result. So the supervisor is responsible for collecting the results and showing, correct? So if I copy this, CLS, and paste. So let's run this. Let it run. As usual, it will take 2 minutes. Okay, so there is no result here because execution happened, but it could not format any code because we just did not do anything. We just returned plain message, correct? So in the tool. So if we had done any processing, it would have returned. So let me explain the code again. So I created a Olama agent. Then we created tools. We know what tools do. We learned it yesterday. It does processing. So here we did not do any processing. We just return some dummy message, correct? So now what we do is tools. Using tools, we created tools name map. Then we created agent. Within the agent, we gave input, chat history, and agent outcome. Tool names is list of tool names dot keys. We gave the name of the keys. And in supervisor prompt, you are the supervisor agent, correct? And we bind these tools. Then when we run supervisor, we give this agent state. We give these messages. System message is very clear what they are doing. Human message is also very clear what we are going to give as input. And then we call this, invoke these messages, and we get the agent outcome, correct? Now, similarly, we also have execute tools. So it executes the tools based upon the supervisor, correct? So within the state agent outcome is there, it will call these tools calls, the tools which we defined here, correct? Code analyst and doc writer tool that will be called here. based upon name and arguments, and whatever results come, that results after invoking, it will store it in chat history, correct? Now in the root next, it will decide after this call what is the next call to do. So for example, here if you go and see that map, first code analyst was done, then doc writer tool was done, correct? So it will call one after another, and the state graph, it will add call tools, and then it will set the entry point, and it will give the sequence of calls, correct? And after everything is done, it will print the result. Does it make sense, everyone? Yes. So this is how it makes. Now since our tools did not have much logic here, that's why it returned empty. So other than that, this is the flow. So you can see here is a supervisor node and other nodes which will help in the call, correct? So this is hierarchical one. Now same way, so we did sequential, we did hierarchical. The next important one is parallel, correct? In parallel, we can have agents which can run in parallel, correct? So naturally we will require a library which can run in parallel. HTTP/x is a library which allows running in parallel, correct? So what we did here is we made use of Olama URL, we made use of model name, we made use of timeout seconds. Now I am creating an async function, fetch Olama response. It takes a prompt and it takes a task name. So here in the payload, model equals model name, prompt we give prompt, task name and prompt, and stream we say as false. Now what we do here is using async client. So this HTTP/x can make asynchronous call. A request and all can make synchronous call, but HTTP/x can make asynchronous call. So we are creating an async client with timeout of 5 minutes. And we say client.post Olama URL and whatever payload we have, this payload, correct? And we wait for the status from the response. Whenever response comes, we convert that to JSON and we say task name is finished. So here we will get the task name and the output of the task name, correct? So either it will have output or either it will say no output formed. Now what we will do is here I am creating one more function, run parallel analysis. So here the same thing which we saw in the slide, analyze the market sentiment for Tesla and determine the key financial risk for Tesla in Q3 based upon expert opinions, correct? So these are two independent queries which can run in parallel. So what we do is we call this fetch Olama response method which we created. In first one, we are passing the prompt and the task name, correct? For each of this. So this is the prompt and sentimental analysis is the task name. So we are given the task name and prompt. Agreed? And second one was financial risk analyst. So both can run in parallel, and to combine their results, when the results from both comes, then only I will show the output. We make use of async io.gather. So this async io allows us to get the results from each of the executions, and that results will be given in this parallel result, correct? So what we do is sentimental analysis this, financial output is this, and we then finally call fetch Olama response again and ask it to aggregate, correct? Aggregate the result from both of this. And once you do that, it will show you the result, correct? So if you see the user input I gave, give me an investment summary of Tesla. So it will go and call this run parallel method in which we have the user query. The user query will be passed here, correct? For sentimental analysis and financial analysis. When result comes from both, that will be given as an aggregation prompt and final result will come, correct? So timeout we have to increase or decrease based upon where we are running. Since we are running this in our local, that's why I gave 5 minutes, okay? So if I copy this, come back here and say CLS. See, starting sentimental analysis, renal analysis. So both of them are running in parallel. It's it in our local Olama only. Both are running in parallel. Both are hitting the Olama. So you see, sentiment analysis is done. So we are waiting for the other one to do. So since everything is running in parallel, you can imagine the benefit of saving time which we will get. Correct? So we'll get a huge benefit by saving time. We're just waiting for the financial risk analyst to complete the task. And then we will, yes, so that is also finished. Only aggregator is pending. And then we will get the final output of the aggregator, correct? So you see the advantage here, it's running in parallel. That's the biggest benefit. Of course, you will have to use a different library like HTTPX, but it's worth exploring given the benefits, correct? Once the output of aggregator comes, we'll go to the next example. See, this is the output which we got. So you see, parallelly, by running parallelly, we got the advantage, correct? Perfect reply. See, perfect answer. Does it make sense, everyone? So thanks to this HTTPX module, using this, we are able to do async await. Correct? So I will explain the code again. We define a function which actually takes prompt and task name as argument and calls our Olama model. Okay, so and expects the response. Correct. This is the first part of the code. Second is we have run parallel analysis. So here we have the user query. In the user query, we want two tasks. Task number one is sentimental analysis, and second one is financial risk analyst. So using these parallel runs, we are able to give this as import to async.gather. Correct? We are creating task which will fetch Olama response. It's a list. So it will call this fetch Olama response for each of the prompt. And when I say async io.gather, this will run parallelly. Whichever results come will start printing, and that result is what we are using for the final aggregation. Correct? See, so this is a great example of parallel. So we learned about parallel also, and same example has been implemented here also. Correct? So next one which we have, yes, is dynamic handoff. So let's go for dynamic handoff example. So here again we are making use of LangGraph and Olama model. So first I created an Olama model and it will hit this URL. Then what we do is we create an handoff state. So in the handoff state, we are having request, topic and response. Correct? So we are maintaining this class and a state which will indicate to us of how the handoff can be done. Correct? So handoff, if you remember, that if the initial agent is not able to answer the question, it will forward that request to specialist agents which will handle this question. Correct? So in the router agent node, state colon handoff. So the router prompt says analyze the user request. If the request involves complex math or statistics, set the topic to math, otherwise set the topic to general. Output is only a JSON, topic, math or general. Correct? So based upon the user request, it will decide whether it is a mathematical question or a general question. So in the messages, again system message, you are a routing expert, output only requested JSON structure and then human message. Correct? So whatever human gives, that will be forwarded, correct, to the system message. Then what we do is Olama LLM.invoke messages, content.strip. So whatever response comes, that I load, and from that I get the topic. So there are two options only. Whatever topic comes, that topic I will get. If not, I will set it as general. Then, so this is the first step, router agent node. Second is specialized agent node. Okay, what will the specialized agent node it will do? It is specialized in solving statistics problems step by step, correct? And we gave the system message that you are a brilliant mathematician. Then what we do, olama.invoke whatever message we had dot content, and we are waiting for the response, correct? Yes. And we have general agent node. So the general agent node, what they will do, you are a helpful general assistant, and it will just give a general answer to the question, correct? So we have two nodes, specialized nodes, general nodes, and the first one, router prompt, router agent node, correct? And route to specialist, correct? So if state is math, we then route it to specialist. Now what we do is we make use of state graph. So LangGraph can create a graph, it can create a workflow. So here we say workflow equals state graph, handoff state. I add router, specialist and general, correct? So router agent you know, specialist agent you know, general agent you know. So from router it can either go to specialist or either it can go to general, correct? And I set the entry point as router. And then we have a conditional node. If route to specialist, then go to specialist or else go to general, correct? And anyways, either it goes to specialist or either it goes to general, it will end. That's the final state. And then we say workflow.compile. And now I am asking a question, calculate the standard deviation of following data set. So when I invoke this request math question and I'm given topic and response, naturally what will happen, this question will be forwarded from the router. So it will first go to the router. So in router, when it gives this question to Olama model, based upon the question, it will give topic as math. Correct? So when the topic comes as math, as per the workflow, it will go to the specialist. So the specialist prompt will become active. It will fire this question, and whatever result come, that result it will show. Correct? So this is how the state graph works. The state graph is basically used to create a workflow. Says entry point is router, ending point is end. From router, it can either go to specialist and general. And how it can go? It can go based upon route to specialist. Correct? Function. So if the output of this function is math, it will go to specialist. Else it will go to general. Correct? So this is how we have defined. So let's run this. Copy path. So come here. CLS. Python. Dynamic handoff. So let's run it. See, handoff happened to specialist. Handling complex math ask. So routing did perfectly, correct? So for mathematical question, it was able to determine that the question is of type math and forward it to specialist. So waiting for it to give the result of this mathematical equation. You see, routing happened properly. So while it still runs, let me explain the code again. So here we make use of LangGraph, correct? So in the LangGraph, I give end of state. End of state does three things: request, topic, and response. Okay. So for the router agent node, it makes use of this and state object. Now we make use of request, correct, from the state object which we passed, and we create this prompt. So the first router prompt is to decide whether it should go to math or whether it should go to general, correct? So it will see this. Based upon that, it will give it to the model. Model will decide based upon the question and give the response, because we were very clear that the output should only be JSON, correct? Now then we have the specialist agent. Specialist agent is going to solve complex mathematical problems, correct? So we are again invoking the LLM with that, which will solve this. And the general agent mode is just going to make use of again the same Olaba model, but it will invoke messages in a general mode. You see the prompt is different, system message is different, correct? And then what we do is route to specialist method is there. This method based upon the state, if the state topic equals math, it will give specialist, else general. Then we create the state graph, we add node as the router, specialist general, entry point we set as router, then we give router to specialist and then specialist, correct? And finally it will both end. Then we will compile this and use this. See, we got the answer finally, and it gave step by step because we are given step by step. So first add all the values, divide it, then calculate the deviation from mean, correct? Then square it and add it. So you see it gave a proper result step by step. So you see, very powerful handoff. It's a famous interview question: how can you handle handoffs in the case of agentic AI? So this is the way we can use. We can achieve it with the help of LangGraph, correct? Yes. So this is also done. Handoff one is also done. Now, so that leaves us with self-correction, correct? Self-correcting agent. Yes. So you see, we have a pattern in which we have a generator and evaluator, correct? So generator will generate a content, with evaluator will evaluate, and based upon the evaluation results, the generator will take the feedback till the feedback is reached and then give the response, correct? So we import Olama. We have this evaluator optimizer function. So role is user content. Write a short Python code snippet of the topic, whatever topic they pass. Then what we are doing is, see, always we require a terminal. See, we cannot go infinitely in the feedback cycle, correct? So we always require a threshold. Now here we are given three improvement cycles, correct? So olama.chat, I am saying Llama 3 model. This is the messages, and we are getting the current content, correct? Yes. Then what we do is we make use of Olama model only for acting as critic. You're a senior code reviewer, check for bug security. Now we get the critic reason. In the critic reason, if we get the message as pass, now based upon this, if it's perfect, say pass. If not, fail, followed by specific feedback. See, we are given very clear instructions. So here, if critic is upper, pass, then we return the content. Else we create an assistant and we give the current content and we give the message. Please fix the code based upon the feedback, correct? And we take this critic value, which again comes from here. And this cycle will repeat 3 times, as you know, correct? After 3 times, whatever result is there, that will be shown. So here we are writing evaluator optimize connect to SQL DB and list tables, correct? This is the code. So let me run this. So again, I will explain the code. So in evaluator, we will always have improvement cycles. Improvement cycles will have a upper limit. So first one generates the code. That code is passed as input to the second model, which will do the review. And if everything is good, it will give pass. If not, it will give fail with specific feedback comments, which in the next cycle or next run or next iteration, the original model has to correct. Okay, so this is a self correction one. So if you copy this, come here and run this Python self correction. Yes. So it will run. So since you're going to run 3 times, it will take couple of minutes, but the output will be a code which will generally good. It will take couple of minutes to run. It's running. So while it running, let me explain the code again. So here we have a generator and reviewer, correct? So we give two different prompts, one to generate and one to review. So in the generator will generate the code. Will also try to take the feedback, correct? And based upon that, it will generate. It will run 2 more times if the result is not proper. So you have to wait. Okay, so same way it will run. Let it run. While it runs, then we can go for the next example. So hopefully the self-correction one is clear on how it works. So then we are left with auction-based one. So what happens in auction-based one? There is a broadcast, correct? We learned there is a broadcast based upon, so there were more than one agents waiting. So based upon the skills and the efforts, the best one is selected, correct? What we do here is we make use of chat olama. I make use of a class agent bidder. So in the agent bidder, we will have name, specialization, and cost, correct? The two major things which are used, specialization and cost. Then we have the bid method. So in bid method, what I am doing, I am checking. So bid method takes two things. It takes self and task description. I am checking. If specialization is lower and competence score, correct? I am generating a random number and just ensuring randomness. And then return in the agent name, cost, and competence score and estimated time, correct? So we have execute task in which we are again having self and task description, which task executed by self dot name, self dot specialization, result is this. Now what we do here is we make use of an auction manager. So the aim of auction manager is to conduct auction. So it will have a list of agent bidders and the corresponding LLM, which is the judge. So in the conduct auction, what it will do, it will ask all the bidders to bill for the task description. Whatever results comes, that I am dumping using JSON. And in the contract manager, based upon this bids str, I am trying to identify the best one, correct, using LLM. And whatever the one which is the winner, that will go and execute the task. Okay, for example, here if you see, the research bidders are agent bidder, agent bidder, agent bidder. One is financial, technical, and general. Find the latest news on AI stock. So when you run this, it will run and correspondingly give the output. So in the earlier example, cycle 2 is running. So I will just wait for it to complete. It will take 2 more minutes and then we can run this example, correct? Let's just wait for a minute. So you can see it cycle 2 also ran. It gave you the output for missing the minor issues, and cycle 3 is also running. Only because this is running on our local system, the speed is slightly slow. Otherwise, it would have come at a faster rate. So once this run, we will go for the auction based one. So while it runs, let me explain the auction based one again. So in auction based one, we have a agent bidder which will bid. It will check the specialization. It will see the competence and estimated time, correct? Now for our example, we are using everything as random, but in real world, it will have some prefixed values. Then we have execute task, which is just saying task completed, correct? So this is all part of the agent bidder. Then we have the auction manager class. So what happens in auction manager is it takes a list of bidders and it takes a LLM which will judge the bidders, of course, based upon their competence and expertise. So that is done in this contact auction method, in which the bidders bid for the top description. We convert everything to a string of JSON and we ask the judge prompt to decide who is the best winner. And that best winner will then go and execute the task, correct? So, and then we created sample bidders and then we are going to call the auction manager to get the best one, correct? We just wait in. As you see, overall, the earlier example in which we had the evaluator and the reviewer, the generator and the evaluator, correct? That example is currently done. Yes. See? Perfect. So now we are free to run our this example. So let me go and copy this. We clear the screen and run this auction based approach. It's a very powerful pattern where bidders bid. Correct. And based upon them, we take a decision. So you see the manager is judging the best bid, and based upon the bid, the execute task will happen. You see, tech researcher was the best, offers the best balance. You see, it checked the tech researcher had the highest competence. Of course, it was generated by random number, and affordable options were $75. Yes. Overall, the test researcher offers the best solution, and we executed the test schedule. Hopefully, that makes sense. So we learned a lot of patterns today. These are very powerful patterns, and they are all famous interview questions. Sequential pattern, hierarchical pattern, parallel pattern. We also learned dynamic handoff and auction-based patterns. Correct. So there are few interview questions pertaining to this. Let's go and see that. Self-correction with auction-based we did. So this is the first question. You are tasked with building a system to generate weekly news summary, explain the difference between sequential workflow and hierarchical workflow, which pattern would be more efficient if you needed to pull data from two independent sources simultaneously, and why. Correct. So we need to pull data from two independent sources. So sequential pipeline, there are agents. Output of one agent becomes input to another. In hierarchical workflow, we have a task which is divided into subtasks, which can be run by the hierarchical, correct, in agents. But if you ask me very truthfully, the best answer to this question is parallel based workflow, correct, which we learned, which can run in parallelly and give the outputs. Okay. So if you see, sequential workflow is linear, fixed order, one agent feeds to next, good for clear dependencies. Hierarchical, central planner, supervisor, delegates the task and aggregates results, good for complex refresh and managing specialized sub-agents. But now, since the question explicitly asks that it should pull data from two independent sources simultaneously, we will prefer more of a parallel-based solution, parallel-based design pattern, correct? That is the best to be used for this use case. Get it? So, next question. In an advanced agent system using LangGraph, with agents powered by Olama, you implement iterative refinement loop, where a writer agent produces a code and critic agent reviews it. If the critic agent fails to approve the code after 5 iterations, how would you design the LangGraph structure to prevent an infinite loop, and what mechanism you use to hand off the failed task to human for intervention? Okay, so here you see, this is the exact point I was saying. If you don't handle critic evaluator model properly, it will result in infinite loop, correct? So to avoid that, the candidate should mention use of state variable like counter conditional edges. There should be a step in which there should be an intervention node. If you remember LangGraph, we can create a graph, correct? So in that graph, there will be a step, something like sending an email or Slack message, or writing the task to a specific queue, or you can also do handover to another agent who can resolve this, correct? Yes. So there are multiple ways of handling this to provide infinite loop. It's a very common issue. Even in many powerful tools which are given nowadays as one of the solution, this happens, correct? So it's a very common problem. So it's better to include a state within the LangGraph which will take care of this. Okay, so let's recap what all we did today. So today we started with sequential workflow. I explained how sequential workflow works, what is the working principle of sequential workflow. Then we went for hierarchical, where we have a supervisor sub-agent model, master, rather than say master slave, with supervisor and sub-agents, correct? Same way, then we went and learned about parallel processing. We made use of the HTTPX library to make use of this async await calls. And we also learned about dynamic handoff. So dynamic handoff is very important. When an agent is not capable of solving a problem, it can request to be forwarded to the appropriate specialist who can handle it, correct? We saw this example with the help of mathematical formula. We also went for self-correction loop. Self-correction loop means there is one agent who will generate and there is another agent who will evaluate, and based upon generation and evaluation, the best one will be given the answer. And one of the important points we have to consider here is there should be some terminate condition, correct? It cannot go on infinitely. There should be some condition in which you have to stop. And finally, we also learned about auction-based delegation, which is also known as contract net protocol. So here what we did was we made use of bidders and auction manager. The auction manager will, out of the list of bidders, will select the bidder who, both in terms of cost reduction and in terms of improved efficiency, and based upon that, that particular one will execute the request task, correct? So these are the different powerful patterns which are used in multi-tool agent collaboration. We have done all the patterns right from basics to advanced. So sequential, Hierarchical, they fall under basic. Dynamic decision making, parallel processing, they come under intermediate. Dynamic and of self correction, auction based, they come in advanced. So we have covered all different types of patterns of multi tool agent collaboration by using different patterns right from basics to advanced, correct? So that's what we covered as such. Hopefully you all enjoyed this session. We did lot of examples with LangGraph as well as Olama models as well as Screw AI. So that's what we have for the session today. Hopefully you all enjoyed the session. We will again catch up tomorrow to learn something new. Thank you. Thank you, everyone. Yes. So one more point which I want to just show you before we call it a day is what all topics are pending. Just give me one sec. Let me share the screen again. So go here. So in Agentic overflow, yes. So what all we finished? So till now, in this week, we covered introduction to Agentic AI, LLM models, and prompt engineering. We also learned about how to build simple agents. We also had tools and memory reasoning, React especially, correct? We also learned about RAG. We then went for multi-agent systems and agent collaboration, correct? So all this part we have covered till now. Now integrating APIs and external tools we did yesterday with cryptography, but we will do few more examples pertaining to this. And then custom agent workflows, tasks decomposition, a part of which we did today. If you remember the hierarchical model and vector stores, so we will deep dive into virtual vector stores. Till now we made use of only FAS. We will also make use of ChromaDB in the coming up sessions, and then we will finally go for capstone, correct? So this is what we are intending to cover in coming up days. We are till here where we covered all the topics right from agentic AI, what is agentic AI, and going step by step in features pertaining to LLM and agents, correct? All the way till here we have reached. So hopefully that makes sense, everyone. And the codes are one which are running. That's a very important, correct? So all the code which we gave are running, and we are also able to use tools like Olama, which runs on the local, correct? So otherwise, if you use anything, so the same code can be also used with any other model provider like Olama. You can also use it with Gemini or Chat GPT APIs, correct, or any LLM providers, correct. But we did it with Olama on the local because it's possible to run various models with no cost involved, correct? So it's very good for people to learn. So that's the intention of using this. Of course, it will take slightly more time if your machine is not powerful. But when you are learning something, it's worth good to invest that much time, correct? So this is what we learn as of today. So thank you everyone. Hopefully you all enjoyed the session. We'll again catch up in coming up days to learn something more. Correct? Thank you.